This is the previous state of the supermarket. As you can see, there are no standardized bin sizes. We have a small bin here, several large bins, and then another small bin. Down here we have 2 small bins, 2 large bins, small bin, 2 more large bins. So you can see there's no standardization there. There's also no grid dividers. This setup is designed to be a grid, but there is no division between bins. There's also no standardized number of bins per row. So you can see we have 5 bins here, 3 bins there. These parts are also sorted by cell. Cell 1 is on the front, cell 2 is on this shelf, cell 3 is on the back of the shelf, and there's also an overflow area where more important parts are stored.
In this video we're going to go over problems we hope to fix with the old system. So, some of the problems we wanted to address were 5S type problems. We wanted to standardize the size of the bin to the size of this bigger bin, so everything was could be held. We wanted to standardize the number of bins per row to 5 bins per row. And we overall just wanted a neater appearance so it'd be easier to spot defects and problems in the supermarket before they became an issue. We are hoping that by making a neater grid and a better grid, we could reduce training time. We also hope to reduce the pick time by ordering the bins based on the pick frequency. We assumed that there were 3 shifts at 7 hours each, so we assumed there were no infinite parts. And part of us assuming there were no infinite parts was reducing the width of all the parts, and to do that we used the real prices that we found on the internet for the parts. Alright, and this is the present state after our changes to the supermarket. In another segment I will tell you a little bit about those changes, but right now we're just going to go over the hardware changes in here. So one of the first things we did is change these labels. The labels are now colored, they're much neater, they're not handwritten anymore. And we standardized the bin size. As you can see, they're all this one standard bin size throughout. There are 4 walls. 3 of the walls have 25 bins on them. The last wall, which is used the least, has 20 bins on it. We used a heuristic in Excel to order these by the number of picks that we predicted would occur every hour. We validated that during our testing phase. Generally speaking though, the orange wall here would have the most picks every 1 to 3 minutes. The blue wall is going to have every 3 to 6. This red wall is going to be every 6 to 8. And the green wall will be everything over that, usually 10 to an hour. The lab runs that we had were 30 minutes. Oftentimes we'd only see 1 or 2 picks from the green in that 30-minute time. We'd see far more from the red and blue. The expected savings from changing this hardware though was going to be basically an hour a shift. So every worker you have in here is going to save an hour per shift in travel time. It adds up as they go back and forth from these bins to their stations. It's a couple of seconds every time they would every time they get to go to one of these closer ones instead of the green. So other hardware changes, we gave each wall a color, as you can see, orange, blue, green, and red. And there's a grid on each wall, just like a battleship grid. So A1, orange A1. And what's going to happen when you're a material handler, you're going to pick up a bin, say this one. Let's see if we can get it in focus here. We cannot. Anyway, it is part 54, container quantity 26, and then where my finger was, that is the supermarket address. Supermarket B2, the card is orange. So if it's empty, and I'm the material handler, I go to the orange wall, simply go to B2, and fill it up. So you can see it's the same part. It's very easy to use, very intuitive. A lot of the material handlers we talked to were saying they preferred the system. They said it was much easier to use. I don't think any of them said they preferred the old system to the new setup. Several of them mentioned that it was a lot easier to find parts. They seemed like they were saving time. Very positive feedback from these hardware changes. These changes were made mostly to set up for the RFID. So for our current state for the RFID system, each bin in Station 6 has been labeled this way. This little paper thing here, that's the RFID tag. It holds all the information on this part that you need to refill it. So what's going to happen is when you run out of part 59, you're going to take it, you're going to scan it down here, and then place it on the back, just like you would for a regular empty bin in the system. As you can see, all of the hardware is screwed in under the station here. It's not in the way. It's just a good setup for it. So when I scanned it just then, it sent a signal back to the screen of material handling. The screen of material handling is going to give you the address to go to, the wall, and the quantity to refill. So it says part 59, quantity 26, A2 or A1. So we're going to go to green, A1, part 59. There's the part I need to have refilled. It's very quick. A major improvement over the previous system. Now I want to discuss the future state for the RFID system. In the future, we hope to move the antennas. So stations 6 and 7 and stations 9 and 10 will share antennas. They'll be mounted in the back here, and then there will be a drop box, sort of like a movie return. So when you're done, you'll take your bin, you'll scan it against the antenna, and then just drop it into the drop box. That will send a signal back to material handling, who will then begin to refill the part. The part empty box collector will only have to come through and collect the piles of bins. They won't need to take them individually from the station or refill them individually, because they're already being refilled in the station as it's happening. So they only have to pull what they need, and it will be refilled as soon as it's empty, instead of having to wait for the material handler to return from the station. For Station 8, we hope to do the same thing, but it will get its own antenna, because it's independent of these other stations. So that's where we hope to have the RFID system in the future.